Hello. Today's video, I'm going to be talking about decision table mapping, a new business map that we've introduced into coreBOS and we just released. And I'm going to kind of show some examples and how it works and kind of go over the documentation. The map itself is based on the decision model and notation definition. This is a standard definition uh, from the OMG organization, and basically it serves the purpose of making a decision or structurizing and automating a very well-defined way of making a decision in a computer system. So we we read the documentation, learned how the DMN was working and what they recommend. And then we adapted that to the coreBOS reality. So we can actually make decisions inside the context of a record or using the coreBOS workflow expression language instead of the field, which they recommend as a language, because we already have the workflow language and it's a lot more powerful anyway. So we kind of adapted it in the same kind of logic. Okay, so the documentation on the wiki has a whole bunch of references here. Very interesting. We'll see a little bit of some of them in the video, I hope. It's all here. It's all documented. It's all explained very well. So you can get an idea of the basis, the theory of what we use to create this business map. Okay, the business map itself is actually to make a decision. Okay, so we have a set of conditions, variables with values or records in the system, and a certain situation. We have to decide a result, some number or some text or some sum of some actions or some numbers, whatever. And instead of going into the code and programming that, we actually now can create a map uh, with the conditions that we need, and then either using the expressions and some context variables or using modules, records in the system, we can get the result back without having to code a code of line in coreBOS. Uh, since coreBOS already had condition expressions and condition query maps, which are very similar, in the end, a condition expression can execute expression in the context of a record and give you a result, tell you if it's true or false, or if it's 20 or 40 or whatever it needs to do. We actually enhanced the decision table map with the possibility of deciding a rule based on an existing condition expression or condition query. Okay, so you can actually use the conditions, those two maps, inside the context of the business decision table map. And then we enhanced it a little bit more, where so you could actually just put directly an expression, which is very similar to the condition expression map, and and then do the whole decision table structure as recommended by the DMN specification. The map itself is defined here. We have a hit policy, which I will explain a little bit. The accepted values are these: UFCARG. We can aggregate. I'll show an example, a few examples of those. Then we have a set of rules that have to be evaluated. All rules will be evaluated. The sequence is important of the rules, so that they can get executed in order. Well, really returned. The results are returned in the sequence order. Here we have this first rule here in the documentation, which is an expression. Okay, so it has an expression directive and it has an output. And then we have another rule here, which is a business map, a condition expression or a condition query business map. So you just give the ID and the decision table will load that map and execute it inside the context of the decision of this other map. And then the other type, okay, so actually each rule can be of one type. An expression, condition expression map, or it can be a decision table. And this is really the interesting one and the innovative one, that this map brings. The other two we already had. Decision table has a module. Okay, it has to be executed. The rules or the conditions are saved in a module in the application. So it could be any module at all. You could have this doing some rules on the account module, looking for some, I don't know, employees or status of the accounts or anything, or invoices by the totals or the subtotals of the invoices, by grouped by the accounts or whatever you need to do. So we have to tell it the module that we're going to do these, that we have our rules or our conditions on. We have a global condition section here where we can kind of filter the whole set of records. Okay, so that is the purpose of that, is that if we're searching on the accounts module, maybe we just want a certain set of accounts, like maybe, I don't know, the ones that are in Spain or that are in wherever, Italy or whatever. So you have a generic set of conditions that you can kind of filter the whole set, the whole modules, the whole set of records on the module. I'll give an example of that also. Then we can order those records, and then we have actually the searches. The searches are where we specify the conditions that we want to search on, the rules that the conditions that have to be fulfilled to know if a rule passes or not. Okay, so if we have to make a decision of those accounts that have more than 22 employees, that 22 employees would be on this search section. Okay, and then we have basically the output, which is telling us, okay, what of the results that this rule returns, what do we want to get back? We can actually get the result of the expression. In other words, whatever the rule returns, we will return from the as a decision. The rule could return a field name, but you don't want the field name itself. What you're looking for is the value of the field, okay, inside the context of the record. So we understand that you're giving me I don't know, maybe account name, but you want the real account name, not the field. So we convert that in, we look for the account name field value and return the value. And the last one is very similar in the sense that we understand that what you're returning is a CRM ID, an ID of a record of a module in the system. And what you want is the whole module instantiated. You want the whole record, the whole record instantiated. So we give you back the whole thing, the whole account entity or invoice entity, so you can do whatever you need to do with the records. Okay, so return a record, one or more CRM objects. Okay, so it's a pretty flexible map and it works pretty powerful. The hit policies here we can explain a little bit. Basically, it's unique, the U. All of this is from the specification, the MN specification. You can read more about it there. Unique means that all rules will be evaluated, but only one must be true. If more than one is true, then you get an error. It's not valid. It has to be unique. Just one rule has to pass. First is just the first. That instead of failing as the unique does, it actually, if there's more than one, it's okay. But we just return the first one that passes. C is to collection, so it will return all the rules that that pass. Any is very similar to unique in that, it's like unique in the set. No, it's like more like first, really. All the rules are evaluated always, and any means that all of the rules that do pass must return the same value. Okay, so instead in unique, only one can pass, and any, more than one can pass, but they all have to be the same value. So in a sense, it is kind of like unique, but with more than one possible result being returned. Well, not returned, but evaluated. Rule order. This is very similar to collect in the sense that basically it will just evaluate all those that are returned that gives a positive value, and return them in the order that the sequence that we gave above. And the aggregate, the G, is to actually sum, min, max, or count the rules that do pass. Okay, so if we wanted to get the total number of employees, of active accounts in Spain, you could do something like that. Where this would return that. It's more like a report kind of thing, but the decision could be that. Okay, we'll see some examples going forward. The output options I explained, and you can execute this in the code with coreBOS rule, and this is where we're going to start doing some examples. This table here is from the DMN specification. It's the example that they use in the in the explaining how it works. I would recommend that any decision table that you have to make, you actually create this table for your use case, because it's a very easy, nice way of understanding the rule set that you're playing with. Okay, and then you can implement that in the system. Okay, so here it's telling us that the hit policy is unique. We have two input variables, which is the season and the number of guests that are coming, and we have one output, which is the dish. Okay, here the seasons can be fall, winter, spring, and summer, obviously. And the guest account has a certain set of ranges here. If it's small, if the less than 8 people are coming, if 5 to 8 people are coming, if more than 8 people are coming, and it's fall or winter, then we make different decisions. Okay, basically that's what this is saying. If it's fall and we have less than 8 guests, we are going to make spare ribs. If it's winter and we have less than 8, then we're going to do roast beef. Okay, and this is very, very easy to read, very easy to understand. And this is what we're going to be playing with. So the first thing that we have to do is, once we understand, we've created this table and we understand the decisions that we need to make, we need to create a module in the system, in the application, or if we can recycle one of the existing ones, where we are going to save our rules, where the user, the implementer, will be able to create each of these rules: the fall, the less than 8, and the spare ribs. Okay, so okay, not actually. No, yeah, that would be the normal way of going. Anyway, here we have a different example. First, sorry, the first example is using expressions. Okay, so expressions are direct. We don't actually need the module that I was just talking about. We'll need that for the next step, for the next example. This map, this decision map, as you can see here, it says it's unique, just like the table above, and we have a sequence of rules. Each rule is an expression that says if season is fall and guest is smaller than 8, then spare ribs, and if not, we return here a does not pass thing. Okay, so if season equals fall and guest count is smaller than 8, then spare ribs. And then the next condition below, we have, let me close this, and so probably be able to get a little bit more screen space now. Okay, if season is winter and guest count is smaller than 8, then roast beef, else it does not pass. Okay, so this is instead, this is DMN uses a language called field, excuse me, and we substituted that for the coreBOS workflow expression language, because it's, most people that are in coreBOS already know how to use it. We keep on making it better and stronger and faster and more powerful and more flexible, so it all benefits in the end. And you can do really nice conditions like these here. Okay, so actually this map, which is on the wiki, expresses the table above. Okay, so let's jump over to the application. I created here a business map, which is in the business maps module. I have various decision tables already created. They implement those maps. Here I have one, which is the season dish expression. I'm going to open this in a new tab. And here I have basically the same map we were just looking at in the wiki. Exactly the same: season, fall, guest count smaller than 8. Business maps have this have this. I think I can. No, yeah, there it is. We can. We have the and the business map module. We have this test map um, action. Okay, it's not accessible. You have to type it in. It's kind of like a developer kind of thing. You give the test map and you give it the record, and it will show you this kind of output we have down here. I added for the specific case of this business map of this to be able to test it. I added two variables here, which is the season and the guest. So we can actually pass in the season and the guest because that in the end is the idea of the oops, no, this one. Okay, that's the idea of the decision table. You have a series of rules. You give it some variables, some values, real values, and it decides what is the actual rule to the decision to take. Okay, so in this case, I'm passing in summer and guest 13, and it says that I have to serve a light salad and a neat steak. Which actually, if we come over here to the decision table, and we see that summer, no matter how many guests I have, we will always be actually serving that dish. Okay, so if I come over here and I change summer to winter, we have 13 guests, so it says stew is the result. So here we have winter and less than 8. This is not fulfilled. Here it's winter and more than 8. So actually we have this stew here, which is what we need. Okay. So as you can see, and if I eliminate, again, put guest 3, I have the roast beef. Okay. So that's the idea. Now I can actually send in a context to my decision table with the variable season and guest, and it will return the result of the decision. Okay, that is done with this business, with this map here, and these conditions, expressions directly in the code. Okay, very nice. So that means that if somebody decides that instead of eight, okay, this is a decision map. Instead of 8 for the winter, they want some other value. They would just have to change this 8 in the map, not in the code. Okay, we don't have to go to coreBOS code to change anything. We can just change the map here. Okay, the next example is using the same table, the same decision table, the exact same one, but now we're going to move the decisions to the database. Okay, we're going to create a new module, which I created here. It's the decisions rules module. Okay, this decision rules module has it's kind of like a generic rule table where you put your name, the name of the decision you want to make. Here you have some text just to explain a little bit what this decision is about. Here we have a grouping where we can, because this decision rule table module is kind of like a generic, you could create a whole bunch of rules for different use cases. So the grouping is what's going to help me distinguish some decision tables from the other. Then we have 4 condition strings, 4 number strings, and 4 value strings, and 4 number strings to return. Okay, so these are the conditions, and it's kind of generic, so I just put 4. You could need more, you could need less, a better. I would suppose that it would be nice if you have a specific condition for your decision table for your users or your implementers to actually convert these labels into something meaningful. I mean, if we were doing just the season dish, I would put season here and guest count here and probably eliminate all the other ones and just put here dish to serve. Okay, so make a kind of contextualize the decision table. Here I'm just doing something generic, so it serves for many cases. Okay, here we have actually I have created with 2 columns. Yeah, I think the first case is this one. Here I have the season dish. I made a grouping of 2 columns here. Actually, we can filter on that one, so we can just see that set. We have 8 rules here, and it says, okay, if fall goes from 0 to 8, then we do spare ribs. If fall goes from 9 to 10,000, it's stew. And if we come over here, basically that's fall is 0 to 8 spare ribs, and fall bigger than 8 is 2. Okay, so I kind of translated this table into these set of decisions. That's nice because now, as I said before, if any case changes and we want to change this 8 into another number, we just have to edit this record, change the value here, and change the other number there, and the rules will be applied. Okay. As to the map that uses this, I created here the two columns map, and basically, as you can see here, and zoom that in a little bit, make it easier to see. Okay, the table says the map says it's unique. It says it's a decision table. Notice the module. It says that it's going to be searching on the records in the CB decision table module. It's going to order the decisions by sequence, which is a column in that net table. And notice that this is the conditions. No, okay, now the condition is season. No, wait. Conditions. Season equals. Okay. Oh, no, okay. Searches. Okay, this doesn't have any grouping at all. Okay, it's searching on all of them. I didn't even. Okay. Okay. That I was looking for a special grouping condition just to get the one column or the two column set of rules, but it's not doing that. And anyway, it's working. Anyway, um, so there's no, so it's searching. The conditions are in the searches. Okay, so we're looking on the decision table module. We're sorting them by sequence, and then we start the searches, and we say season has to be equal to the value in condition string 1, and the guest count has to be smaller or bigger than condition number 1, and the greater or equal to the condition in number 2. If all of those conditions are met, then we return the value in string 1. And here we actually return the field value. Okay, so we're returning, the decision table is actually returning val str1, but we execute that in the context of we get the record that that was true, and return the value from the database. Okay, so if we take this back and we search here, actually I'm saying search for the season in condition string 1, and then do the range from condition number 1 and condition number 2, and return the value string in 1. Okay, if we come over here to the decision test map and we change this map to this one, this map is 43393. Okay, that was the one that we were executing. Okay, so the expression, I wasn't actually doing the expression. Okay, anyway, the expression works. I tried that one before. This is 43406. Okay, so 43393, this is executing this decision map table. This one, which is searching on this set of records and returning the value that I need. So if I wanted to return the spring for 3 users, which I should get dry aged gourmet, I can copy this string, come over here to the season, pass in the spring, and for 3 users, I will get the dry aged gourmet steak. Okay, so it's actually working very well, and consulting inside the both maps, as you can see, are relatively easy. And now I could change these values here and get the correct values. This is this actually in this idea. If you read the documentation, you'll see that the next example, in this example, I took apart these ranges and put them in 2 columns. Okay, so I could do the search with bigger and smaller than. Okay, in the next column, in the next example that's here in the documentation, instead of doing 2 columns, I'm doing just 1. With 1 column, I'm doing the whole thing. In this case, what I'm doing is doing a little trick here where I put, instead of unique, I'm using the first, the F. So what I'm looking for here is, once I have the season, I'm looking for the smallest row that fills the that fulfills the guest count. Okay, so if I have 3 guests, I'm searching for 3 smaller than 8. So it would find this first record and give me that one because it's the first one. This one is true too because 3 is smaller than 10,000. Okay, both of them are true, but since I'm looking for just the first one, it returns this one and I get the correct value. What I'm trying to say, this is done here with one column grouping. We have the set of rules here with, if you can see here, the condition 1 has the values, condition 2 is empty, and the business maps that we have, the business maps ordered by this one, the business maps we have here, I have a season dish 1 column where I implement this with the hit policy of first. And notice that there's just 2 conditions. The season equals condition string 1, and guest count has to be smaller or equal to the condition 1. Okay, so if I implement this map, which is 43394, I get actually the same results because the season tables are the same. Okay, that works exactly the same, but it's working in a different way. The goal here is that what I'm trying to say is that how you create your decision table and how you make the decisions is really a lot depending on the implementer, how you want to do it, how you want to teach your implementers to create rules, okay? Because basically the rules actually change a lot depending on how you implement the decision table, okay? And it's a lot very flexible, and there's a lot of ways of doing things right. So you have to kind of understand what's going on, and that's about it. About everything that the fundamentals are there. Okay, I did some other maps, which I'll go over really quickly, just to get an idea of what they're for. I did here let's filter these out. Okay, we have season dish expression, season dish 1 and 2 columns. Those are all basically on the same. And then I have 3 more, which are tests that I did for the aggregation test verification. Okay, let's close this one and let's open. Okay, let's eliminate this search so we can see some other values here. I have 2 columns, 1 columns. Okay, and here I have employee salary bonus, which has 4 rules, and car insurance fee, which has 4 more. The employee salary bonus has here a condition where we have 1, 2, 3, 5 years. I think this is the number of years. And here it returns the bonus that an employee gets depending on the number of years that they've been working with. So this one has an input of number of years, and it gives us back the bonus. The thing here is that the bonus actually can be accumulative. So if he's been with us for 2 years, he gets 300, and if he's been with us for 3 years, he gets 600. So we actually need to sum the values that are true. Okay, and in the car insurance fee, depending on the number of years that the user has been with us, 0, 2, 3, or 4, they are applied a different fee. This fee so this happens again if he's been with us for 3 years. Obviously, he's been with us for 2 and for 1. So they're all true, but we want the minimum value. We want to apply the minimum fee that he has right to due to the years that he's been with us. So we have to calculate the minimum that are here. This is coming directly from the hit policy documentation. Here explains the unique with the spare ribs and the like, the any policy here, which I did not implement. First, which we already have in the examples, and then we have rule orders and the collect. These are very easy to test. I tested them while I was doing the video and the testing and the maps and everything. It worked very well. And the aggregators, here's where the those come in sum, min, max, and count, and we have the salary. Here's the example that I was just showing you. It says, okay, we have to collect plus. They do it a little different. We have the G and the sum. And again, as you see, it's more than 1 year, it's 100, more than 2 years, and more than 3 years. And okay, so here I have this map. I have the values here. Okay, again, this is exactly this table implemented in these records in this module. Okay, that's the first. So create the table and then create the module or the records, the fields that you need to implement those rules. Here I have the employee salary bonus amount. See this map. Okay, this map has a hit policy of G, which is aggregation. It has an aggregation of a sum. And it says, okay, in the CB decision table, search on the grouping for salary bonus records. That means that I will get only these salary bonus, these 4. It will not interfere with the other 1, 2 columns and insurance fees that we have here. Okay, just searching on the salary bonus. Order them by sequence. Give the number of years that are smaller or equal to the condition number 1, which is the number of years that we had there, and give me back the val number 1. Okay, so we will get all of the rules that are under these number of years, and we will sum them and give back that value. This is record 40. This is map 43,395. So if I come to the test map, load 43,395, and instead of season, we put number of years. Number of years, I think I did, and we put that to 3. It says 600. Okay, which is exactly what it was supposed to say, because it says the number of years is 3. So it's 100, 200 plus 300, 600. It summed the values up and it gave us that amount. So if I put 2 years, then I get the 300, which is perfect. Okay, so it's very nice, because then if somebody decides that for whatever reason, instead of 100 for the first year, they get a bonus of 110 or 90, you just change the value here and then take the decision again, and it will give you back the correct value without having to change any line of code. Also, the employee salary bonuses, this one counts. This one is a count aggregation. It's counting how many rows are actually true. Okay, so actually this is exactly the same one we just saw, but instead of summing the values, it just counts how many rows are coming back. This is map 43,405. So if I come over here and I put 405, it will say that 2 rules have passed. And if I put back the 3, we should get 3 rules passing. Okay, so you could make a decision also maybe on the how many rules are applied or whatever. Okay, that is the count here also. That's this example here. And then we have this other example, which is the minimum, and I'm going to show you this one on the insurance fee, just so you get a final idea of how it works. Again, the map, this table is very important. In this case, we have the conditions are the number of years coming in, and what's coming out is the fee. Depending on the number of years that you've been with us, that you've been working with the company, you get right to a different fee, and we have to find the minimum value depending on the number of years. So we create a map that looks like this. Car insurance fee. It's again says it's an aggregation. It's returning the minimum value. On the CB decision table, which is the module I created, we first filter from on the insurance fee in the grouping. So we just get the 4 records that we're working with for this decision. And then again, the number of years has to be smaller or equal to the number of years that I saved on the condition number 1 field inside that module. That returns the value number 1 field in that table. And we actually get the field value and we calculate the minimum. Okay, so this map is 43,400. So I load the 43,400 map, and it says that for 3 years we have to apply 98.83. For 3 years we have to apply the minimum, which is 98,883. which is exactly what this table says here. For 3 years, they get a fee of 98,883. And if we change that to 4, then the decision table will tell us that they get a right to the 6432. So, anyway, very powerful, very nice, generic way of implementing these decisions in a way that if they change, if the rules change, which happens too much really. Uh, Business nowadays is very dynamic, things changing very quickly. So we can't actually find the time or wait the time to get an implementer away from what he's working on right now to just change some rule in the code. We have to have a way where somebody can quickly change the rule just by typing in some values in that table. And that's what the decision table map is all about. Okay. I uploaded, just one last note, I uploaded the module to GitHub, the decision table module. It's here on the coreBOS site, decision table. The whole module is here. And also inside this module, I uploaded this decision rule CSV, which is an export of the examples that I was just showing in the video, and also the decision table business map CSV, which is the 3 or 4 maps that I've been using in the video. So you can actually download this module, install it in your coreBOS, import these 2 tables, this one on the decision table, and this one in the business maps module, and you should be able to play with the values I just said. Notice that this test map feature functionality has been specifically changed or adapted to work. Okay, this test map thing is not actually, it's a developer feature. It's not something that that you can use generically. And what's important here is that each decision map has a context. That context, actually, if I let me do a dump of that on screen, so you can actually see what's being sent in. This is for your development purposes later on. Okay, this is the context that's actually being sent into this map. Okay, it's an array where I define the variables that I'm using. Okay, the guest count, the number of years, and the record ID. Record ID is normally very important, but depending on the map itself, because the expressions, the expression rule, and the business map, condition expression, condition query maps, those require the context of a record in the application. Okay, the decision table doesn't, because it works based on the records in a module. So it has everything it needs just looking at the module, and the rules are there. But the expressions, when you put an expression directly, like we did here in the, probably here, it's still here, yeah, in this one, season this, this map is actually executing this season and this guest count. It needs to know what those values are, what variables are. If you put here account name, employees, or invoice total, it needs to know how to evaluate and convert that into a real value. Okay, because in the end, the decision is made using real values. Okay, so that context comes from this record ID. So it's very important that you give it that record ID when you load and execute the decision table. This is the context that I'm filling in when you put here seasons and number of years. Okay, if we did that again, if let me see, probably if I do it like this, I'll have it in my memory. Yeah, good. Okay, so here, notice that my season, winter, was loaded into the context, and the guest count 3 was loaded into the context, and the number of years is by default 2, and the record ID is by default 74, because in this case, it's not even being used because the decision table doesn't need it. Okay. Anyway, just so that you understand that it's very important as a developer when you're creating this, when you're calling the decision map to make the decision and return the correct value to the user, you have to give it this context, and it's kind of important to get that value. Test map has been adapted to get those values and pass them in specifically. Well, the documentation is online, and we are available in Jitter and everywhere on the forum and all the places that we usually are for any help. Thanks for watching.